Okay, so we've got some problems here that we want to work on to find the shear force and bending moment diagram. I'm going to do a little bit of a shortcut here to save some time, is I'm going to go ahead and tell you, and I think you could probably figure it out pretty quickly, what the shear force and bending moment here at the reactions are. I think you can tell me what the shear force is going to be. I think it's going to be up, and it's going to be equal to P, and that's positive shear. And the bending moment will be negative and be equal to PL. Okay? So with that as a starting point, let's draw the shear force and bending moment diagrams. So what is the shear starting here on the left side? It's positive P, right? So far, so good? And what is the change in shear is equal to the area under the load? What's the area of our load curve? 0. So if I start at P and I add nothing to it, I get P. And what is the slope of the shear diagram equal to? The load. What is the load here? 0, so it has 0 slope. So there's my shear diagram. Basically, this beam has constant shear, a positive P. Any questions about that? Now what about the moment? Well, let's start here on the left side. What's the moment at the fixed connection? It's negative PL, right? So I'm going to start at negative PL. By the way, what's the moment at the free end? 0, so I better hit 0. Now, according to my derivative information, the change in moment is the area under the shear diagram. What is the area under the shear diagram? It's a rectangle, so it's just length L times P, that's positive. So if I start at negative PL and add PL, I get 0. Great. That checks. So what about the slope of the moment diagram? It's equal to the shear. And what's the value of the shear everywhere? Positive P. So here's a positive slope. And I'll just go ahead and pencil on there that it's of slope P. So now the question is, what's the maximum moment? Minus PL, where does it occur? Fixed connection. What's the maximum shear? P, where does it occur? Everywhere. You'll be happy if you get this problem on the exam. I can't guarantee your happiness right now. All right, so let's go back, and now what's different over here is that the only load is the moment. Okay? So in this case, equilibrium will tell you that you have a positive bending moment of m naught as a reaction, and you have no shear. But if you sum forces in the the y direction, no reaction. So let's draw my shear diagram. So what's the shear at A, at the beginning point? 0. The change in shear is equal to the load. What's the load over the length? 0. So I stay 0. The slope of the diagram is equal to the load. What's the load? 0. So I have no shear in this beam. That's a pretty easy diagram to draw. Now we'll do the moment diagram. We'll start the left side. What's the bending moment on the left-hand side? Positive m naught. The change in moment's the area of the shear diagram. What's the area of the shear diagram?
No change.
0. So there is no change. It stays m naught. And look at that. It matches the moment. Because that's a positive bending moment. The slope of the moment diagram is equal to the shear. The shear is 0. Here's a curve with zero slope. So this is a beam that has constant moment across the entire length. Any questions about that one? Okay, I'll stop this and we'll move to the next one.